Hi there, and welcome back. On our previous example, we went through a similar example in details, explaining each and every details that you're looking at here in terms of the regression statistic, the ANOVA table, and also this table which provides information about the coefficients or slopes of the regression model. For this example, I'm just going to show you the part of actually attaining these variables in terms of regression statistics, the ANOVA table, and also the slope of the regression model table. Okay, so let's go through this example. Data in table number 2, being this table over here, are from an experimental measurement of a radiative heat transfer gas solid suspension flow system of the calibration of a radiometer. The variables are as follows. Electromotive signals outputs of the radiometer are represented using X in volts. Radiation heat represented using variable Y in kilowatts per square meter. So here is our Y variables versus X variables, and these was given representatively accordingly all the way to this values over here. Now, based on this table, we are asked to write the equation of the fitted model. For B, using the coefficient of determination as system model, and C, using the F statistics to assess them. In case you're wondering how can one do this plot here, please watch this video. And use the data analysis function. I actually don't have it here on my Excel, so I'll manually have to add it as an add-in under my data. So let's go to Files, navigate to Options, Add-ins. Under Excel, we are going to click Excel Add-ins, Go. They're actually selected. Okay, we are going to click on Analyze Data. Navigate to Regression. Okay, let us identify our Y variables. Enter. Next, let's identify our X variables. Enter. Let's proceed. Oh, there's an error actually. This variable here is entered wrongly. So just gonna say cancel. Cancel. Let's fix this. Must be numerical, comma, perfect. So let's analyze again. Regression. Okay. Identify your X variables and Y variables. So this will be our Y. Enter. Let's identify our X. Enter. Okay. Perfect. There is our table that has just generated. Okay, now let's proceed. Now that you have an idea of how to actually obtain these variables or this data information here using your Excel, let's proceed to answer the question. So to answer A, we are asked to write the equation of a fitted model. We are going to focus on the intercept. Like I said previously, we went into details. Now we're just going to try and just answer the question as it is. So we're going to look at the intercept and also here our X value. Answer B, the coefficient of determination to assess the model, we are going to look at our R squared. Also actually look into our adjusted R squared and R as well to assess the model fitness, but they say use the coefficient of determination that is away from R squared, and using the F statistics, keep in mind of our F value and our P values as well as we are going to answer the question. To answer the first question, like we said, we are going to write our equation in the form of a linear expression. So our intercept, the X variable was written down as well. Hence, we can express our equation in this format over here. Secondly, we are asked to use the equation of determination to assess the model fitness. Because we got R squared is equal to 0.996, it simply means 99.6% of the variation is explained and accounted for, and only 0.04 is unaccounted for. So definitely this model is effective and super fit compared to our previous model. And lastly, use the F statistic to assess the model fitness. To answer C, we basically are going to assess the model significance by comparing the F value to the critical value at a given significance level alpha. In this case, let's assume 0.05. So we are going to check if the p-value is greater than alpha. If you check here, the p-value is way less than the value of alpha. Hence, we are going to reject this analysis. I really hope this makes sense. Thank you so much for watching.